Welcome to solverfy.
This is another problem that has an outlier that we'll have to deal with, but I'll go ahead and wait until it's relevant before I go over how to adjust for that. We will want to start as usual by finding our minimum and maximum. Our minimum is 6.2 and our maximum is 70.4, but since that is an outlier, it's going to really mess up our classes if we use that one. So we're going to ignore that data point and use our next highest maximum. However, for now, I'll go ahead and show you what would happen if we did use 70.4. This would give us a range of 64.2, which would give us a width of 10. So then we would have a new chart down here where our first class would go from 6 to 15. Our second class would go from 16 to 25, and so on down to 66 to 75. And now you'll soon see why this is a very bad idea, because almost all of our data is in this very first class, and then we'll have a bunch of zeros, and then our very last class will have one data point. So everything except for the outlier ends up being in this very first class. This is about as useless as a frequency distribution can possibly be, which is why we do not want to do it this way. I'll leave that just so you can see it for later, but I'll go ahead and erase this so we can solve the actual problem. So now we'll use our next highest maximum that is not an outlier, which would be 12.3. This gives us a range of 12.3 minus 6.2, which equals 6.1. And we'll want to divide our range into 7 equal classes. When we divide by 7, we get 0.87. Normally, since our data does go into the tens place, we would round to the nearest whole number. However, it just barely goes into the tens place. If it was something more like 70, like our maximum, 70.4, then I would definitely round to the nearest whole number. However, most of our data is in the ones place as our maximum place value. So I'll go ahead and round to the nearest tenth, and that will give us a little bit better data. So our width will round up to the nearest tenth of 0.9. Now we can finally construct our classes. Our starting point could be 6.0 or 6.2. I'll go ahead and just use 6.2 for this one. It doesn't really matter which one you pick. Now, to find each new class, we're going to add the width. And so our next starting point will be 7.1. And just keep adding that width of 0.9 to get each new starting point. 9.8, 10.7, 11.6, and I believe that is our 7 classes. Now we can go back and fill in our endpoints by just comparing to the next starting point. So we need to end at 7.0 since our next one starts at 7.1. Then 7.9 comes before the 8.0. Then 8.8, 9.7, 10.6, 11.5. And this last class needs to include our outlier. So normally this would go up to 12.4. The only reason I want to write that in is we want to make sure that our maximum would normally be included in that class. So our maximum of 12.3 would fit into that class, so we have set it up correctly. This actually means that 6.0 would not have worked after all. So your only two possible starting points could have been 6.1 or 6.2. If you had rounded your width up to 1.0 instead of 0.9, you could have started a little bit lower. Now, since we do need to include that outlier, like I mentioned, we're actually going to make this last class be an open-ended class, which means we'll just say 11.6 plus, or you could write out 11.6 and above. Now we just need to count up our frequencies, and for this you should end up with 1, 6, 6, 7, 6, 5, and 5. Your frequencies could be a little bit different if you had set up your width and your starting point differently, but it should look very similar to this. The most important thing is that your frequencies should add up to however many the total number of data points were, so that is a good way to double check yourself.